All right, so let's talk about section 2.6. This is about proving angles congruent. We're going to add a few more theorems to our list, but that's okay. So first of all, a theorem, here's a definition if you're wondering what a theorem is. It's a conjecture or statement that you can prove true. So we are actually going to prove a few of these theorems true today. Whenever you're doing this, you can use it just like a property or a definition. This can be a reason whenever you're on the reason column, whenever you are writing a proof. So you can add these theorems to your list. So the first theorem we're going to talk about is the vertical angles theorem. And we've talked about this before. It just says that whenever you have two lines that cross, they make an X. The ones on opposite sides, so like 1 and 3, they're congruent or equal. And then 2 and 4 are congruent. So now we're going to use that theorem to find the value of x. So looking at this problem right here, what is the value of x? And then they have this diagram for us. Well, what do you know about those two angles? Hopefully you're thinking they're vertical because they're across from each other. So they're vertical, which means they're also congruent. So we know they're equal. So let's set up our equation. So it'll be 2x plus 21 equals the other angle, which would be 4x. Let's solve it. I'm going to subtract 2x from both sides. I have 21 equals 2x. Divide by 2, divide by 2. X equals 10.5. So 10.5 is what 21 divided by 2 is. And that's it. The next one here, we have another set of vertical angles, so we know those two expressions are equivalent. So we have 3x equals 2x plus 40. And then let's solve it. Minus 2x minus 2x. You have, that would give you 3x minus 2x is just 1x, or x, equals 40. And that is your answer. Moving on down to our next theorem we're going to talk about is the congruent supplements theorem. So when you hear the word supplement, what do you think of? I think of supplementary. And so that's exactly what this means. So for example, if I had an angle, and remember supplementary means they equal 180. So say this angle was 100. And if the question was, what is the supplement to this 100-degree angle? Well, that would be an 80-degree angle. Because when you add them together, they equal 180. So you could say 80 is the 100-degree angle supplement, or the 100-degree angle is 80 supplement. Okay, so on this one, the theorem says if angles 1 and 3, so angles 1 and 3 are supplements, and angles 3 and 2 are supplements, then 1 and 2, these two must be equivalent. So those are congruent. So they are congruent, which makes sense because they both share that angle 3. So if they're both the supplement of angle 3, they have to be congruent because they're going to, 3 plus that angle is 180, 3 plus the other angle is 180. Those angles have to be the same angle. Okay, this next one, congruent complements theorem. So this is very similar to the last one. Remember, complement means like complementary. So that means that they're going to equal 90. So for example, if I had a 30-degree angle, what would be the 30 or the complement of this 30-degree angle? Well, it would be a 60-degree angle, right? Okay, so this is, almost the exact same theorem. So if angles 2 and 1 are complements, and angles 2 and 3 are complements, then angle 1 is congruent to angle 3. That is it. Okay, the next one, they don't give you a name, but I'm going to give you a name. This is my favorite theorem because it's the easiest. It is the right angles, oops, what am I doing? Angles are congruent, or congruent theorem. Right angles congruence theorem. So guess what? All right angles are congruent. That's it. That's seriously how easy it is. That's why it's my favorite, because it's so easy. This next one, so it is called the right angles supplementary theorem. Okay, and what that means is if two angles are congruent and supplementary. So if they're congruent and they're supplementary, that means they'll be 180. If you were going to divide that into two equal pieces, well, the only way you could do that would be to have two 90-degree angles. That one's not a very common theorem, but you may have to use it eventually. All right, now we get to do a lovely proof. This one actually isn't too bad. So let's talk about this. Well, first I'll make my T-chart. So statements and reasons. So I have, we're given that angles 1 and angle 4 are congruent, and they want us to prove that 2 and 3 is congruent. So, and we're going to use the vertical angles theorem. So think vertical angles. I know you might automatically start thinking supplementary. They add up to 180, but don't go that route. Just think of vertical angles. Okay, so on this one, we're going to start with, of course, what's given. So what is given is angle 1 is congruent to angle 4, and that reason is given. Okay, so now we need to list our vertical angles. Oops, I didn't mean to do that. So our vertical angles, so 2 and 4 are vertical angles. So let's list those. That's step 2. Angles 2 is congruent to angle 4. Why? Well, that's the one on the first page of these notes. That was the vertical angles theorem. Okay, let's list the other set. That would be 1 and 3. So, oops, I'm switching colors every time. I'm not meaning to, I promise. So 3 would be angles 1 is congruent to angle 3. And why? Because of the vertical angles theorem again. Okay, now we're going to use the transitive property. So I want you to look, we're first going to look at the first 2 rows. So we're looking at this row and this row first. So if angle 1 is congruent to angle 4 and angle 2 is congruent to 4, so angle 1 is congruent to angle 4 and angle 2 is congruent to angle 4. What can you say via the transitive property? Well, since they're both congruent to 4, they must also be congruent to each other. So angle 1 is congruent to angle 2. And that's the transitive property of equality. Or sorry, congruence. We have a congruence symbol, so it's of congruence. The next one. So now I'm going to erase these. Maybe. Well, let me erase. There it goes. Okay, so now let's talk about, we're trying to get to 2 and 3. So let's look at the next one. Let's talk about line 3 and 4. So you have angle 1, angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2. So what does the transitive property tell us? So that tells us that angle 2 is congruent to angle 3. And the reason is the transitive property. Did we get exactly what they had us to, or wanted us to prove? Yes, we did, so we are finished. And that is all the steps. Okay, the last proof. Let's just make our T-chart really fast. Okay, so now 1 and 3 are supplementary and 2 and 3 are supplementary. Prove 1 is supplementary to 2. So if this looks, we're trying to prove the congruent supplements theorem is what we are proving right now. So let's do that. First, of course, you start with what's given. So angle 1 and angle 3 are supplementary. And that's given. Next step, let's do the other ones. Angle 2 and angle 3 are supplementary. And that reason's given. Okay, so usually, not on the last proof, but a lot of the times, you'll find yourself that you state what's given, and the next step after the given statement is you're explaining what that means, what that given statement means. And so that's what we're going to do right here. So the first statement was angle 1 and angle 3 are supplementary. So what does that mean? Explain what that means to be supplementary. Well, that means the measure of angle 1 plus the measure of angle 3 equals 180. And how did I know that? Because that's the definition of supplementary angles, right? So then how would I explain on step 2, how do I explain that given of angle 2 and angle 3 are supplementary? Well, I'll do the exact same thing. The measure of angle 2 plus the measure of angle 3 equals 180. So that would be the exact same reason. It's the definition of supplementary angles. Okay. Now, I'm going to go off on a tangent for a second. So say I had, let's say 2 plus 3, what would that give me? 5, right? And then if I had 1 plus 4, what would that give me? 5. So we could say that this statement, 2 plus 3, and the other statement, 1 plus 4, are equal, right? Because they are equivalent. So that is a property that I can see it two ways. Some people sometimes put transitive property, and sometimes people put the substitution property. This time I'm going to put substitution property. So it's like we plugged in all of this in, or actually I should do it the other way. Let's say we plugged in all of this right here, this 1 plus 4, in for that 5. So that's where it goes right there to the 1 plus 4. So that is, again, the substitution property of equality. If you wrote transitive on your test, I would not count it wrong, but try to put substitution. Okay, so why did I do that little tangent right there? Well, because right here we have this one, they equals 180, and this one equals 180. So then we can set those two equations equal to each other. So I gotta write small. So we'd have the measure of angle 1 plus the measure of angle 3 equals the other one, the measure of angle 2 plus the measure of angle 3. And what property was it again? What did I write? The substitution property of equality. Okay, now we're getting really, really close because we're trying to, again, get to angle 1 is congruent to angle 2. So we're almost there. So for next thing we need to do is, well, what are your ideas on how we can get that angle 1 and angle 2 by themselves on either side of the equal sign? Well, that angle 3 is getting in our way, so what are we going to do? Well, we're going to subtract them, right? So minus angle 3 minus angle 3. And we can do that because we did it to both sides of the equation. So that would be the subtraction property of equality. So then that would leave us with the measure of angle 1 equals the measure of angle 2. Look how close we are. We are so stinking close, it's not even funny. How can we get from the measure of angle 1 equals the measure of angle 2? Well, that's just the definition of, because we're trying to get it again to angle 1 is congruent to angle 2. That's the definition of congruent angles. And looky there, we finished it, we got it done. So we finished the proof because we ended exactly how they wanted us to. And that is it. Thanks for watching.